Hey guys, I hope you're all doing well wherever you're located. I'm Abad and I am working as a data engineer at Data Science Dojo. So today we are gonna start, to develop a machine learning application and deploy it. So let's get started. Okay, so about me, I'm a computer engineer. I just graduated 2 months back. My main focus is towards AI and development, and my research is mainly focused towards NLP, natural language processing, and computer vision. And as I told you, I currently work as a data engineer at Data Science Dojo. I joined several months back, and yeah, so that is about me, a brief introduction. So what we'll be doing today. Okay, so we are going to develop an application that will use machine learning with Streamlit. So what Streamlit is, it's a Python package that we use to develop web applications. So for example, if you know machine learning, or if you know deep learning, or even if you know computer vision, but just developing Jupyter notebook won't do you much good, because many clients are non-tech, right? So they need some experience, interacting with it and things like that. So in that manner, that's why we, got this webinar into place, and that's why we are going to use Streamlit, which is really easy framework to use, and it's really user-friendly, and it's really easy. Also, just for the development purpose and just for the time constraint, we are going to use a really easy data set to work with. And it is the IRIS data set that we will be using. So if you have the GitHub repo, the data set is already there, and all the required files are already there. So you won't need to even download anything except from cloning the GitHub repo. So the third thing that we will be doing is developing an interactive UI user interface that we will code using Python. And then we will, at the end of the live coding session, we are going to deploy that into Azure. So at the end of the session, we will have an application. I can simply show you that. So yeah, this is the application that we will be developing. So this is completely interactive. You will see the graph. It will be interactive. You can, change the graph. You can even add things. So the graph is changing, and then you will have a machine learning model incorporated into this web app. So you can simply predict with it. So if you don't know about the IRIS dataset, we will be focusing on that for a bit afterwards. So that's what we will be doing today. Sorry for this. Yeah. Okay, so what will be the infrastructure we like? So the user, we will interact with the code that will be in front of the web application. So the code will be used to develop a web application, and then we will Dockerize it. You don't need Docker. You don't even need to install Docker in a local machine. We will be using Azure for all that. So everything will be online. You don't even need to install a thing for that. Except for the Azure CLI, we will be looking into it afterwards, and then we will deploy it onto Azure App Service. So it's a completely platform as a service of Azure that we will be using. So which means that you won't have to manage that service, or you won't have to scale that service. It will do that automatically. So the flow diagram is really easy. We will be installing some dependencies for the people who don't have those dependencies. They can install those, and then we will develop the application. We will be live coding, and then we will integrate machine learning into that code, and then we will deploy the application. Okay, so that was a really short slide, and I'm sorry it's not that much explain, but as it is a live coding session, so we will be diving into that. So let's go through. This is Visual Studio Code, and let's first see the directories that we have. So we will be having images. We will be having 3 images because we have to show the predicted image. Those are the images that we have. We have a simple plain file that is completely empty. So we will be developing the whole code, and we will live coding in this application. And then we have a Docker file. I'll come right back to it after we have, after we will be deploying. So I will explain a line of it. So you don't have to, worry about this. And then the main part is the data set that we have. So it's a data set that I downloaded from Kaggle. I didn't clean it. I didn't do a thing. I just downloaded it and just put it over here. So it includes 150 entries. 150 entries of 3 iris flowers, Setosa, Virginica, or versicolor. So it's kind of a clean data set, but I just downloaded it from Kaggle. So you won't have to worry about that because it's available in a GitHub repo. Right. So yeah, we will come to the model afterwards. And yeah, the requirements checked. You just need 3 packages of Python. You need Panda. You would need Python, of course. Then you will need Pandas. You will need sci-kit-learn, and you would need Streamlit for the web application. Pandas is used for the data frame manipulation and the data set loading. Sci-kit-learn is for the machine learning, and Streamlit is for the web application that we will be interacting with. So yeah, as we can see, this is a plain file. So yeah, let's start coding. So obviously I have a code snippet right next to me. So I will be, going through that and, live coding it. But yeah, I'll be explaining line to line. So first of all, we need to import a Streamlit at ST. So we need a package that we will be needing to develop the application. So here that is. Okay, we don't need that. So that as I installed Azure package, so that's what happened. And then we need Pandas. And then we need, okay, let's just do it right now because afterwards we'll integrate ML. So yeah, so first I need to put a title that will be iris flower classification. Okay, also we can even run that and see it in real time. So let's do that. I won't be using PowerShell, I'll be using command prompt. So yeah, so what is the command? It's a simple command, Streamlit run, and the file name. What is the file name? The file name is app.py. So yeah, it will take some time to run and it will open on your browser. So let's wait some time and see what we have with just a single line of code. Okay, so here's a URL, but it automatically opens. So it takes some time loading at the first time, but yeah, that's not a problem for us. So yeah, so what it does, Streamlit gives you a web URL that is localhost. After that, we will be deploying it. So it will be a domain name. After that, we just use a single line of st.title that got us the title for this. Yeah. So now what we will do, we will do the data frame that we have. We will simply use pd.read.csv. And what is the data frame name? I'm sorry for this typo. The data frame name is iris.csv. So that is the data frame that we loaded into DF with the use of Pandas. So now what we have to do, we have to okay, I will be going back and forth with the deployed application that we have. So what we need to show this data frame, and then we need to show this graph, and then we need to show these filters for the graph manipulation in real time. So yeah, let's do this. We have the data frame loaded, and then I need to show a sidebar. So what we will do for that, we will use st.sidebar.multi-select. And then I will be putting the string filter by flower. So that is a string that it takes. And then we will put some options over here. So what the options will be, it will be DF. And what is the DF? We have the data frame over here, and we need a species name. Okay, so whatever the species, it is iris setosa, iris virginica, or iris versicolor. So we need to name them as the filter of our. Also, we got all the species over here. So that is 150 rows, but we don't want that. We need only unique ones, right? So what I will do, I will put just unique over here. And then I need some default value that should be always selected when I reload the application. And that will be species, and it can be a 0 to index. So why did I use 0th index? So as you can see in the data set, there are 150 rows, right? And when I call df species, it gets 150 rows. We don't want that. We need any one of the species, right? So that's why I put a 0 index. So let's see what we have right now. So when you first reload, when you first start the application, it asks for always rerun or rerun. So I will just select always rerun. So whenever I save the code, it always reruns without me changing anything. So what did you get? So we got this filter name, and then we got this filter. So what we can do when selecting this filter, we can manipulate the data frame over here and the graph over here. So that will be done in real time. So how we will do that? So in the flower variable, we are getting either iris setosa, iris versicolor, or iris virginica, or all, or both, or even one. So what we will do, we will use a simple query to manipulate the data frame. So what I can do, I can use a query variable of Streamlit, and then I can do species equals flower. Yeah, so that's a double equal because a ternary operator, and then the species is the variable that we have in the data set, and whatever we selected over here, it should be equal to that species. So that filtered data will be in the data df filtered variable. So now we need to show this data frame onto the application. So how we will do that? We will use Streamlit's function data frame, and then we can use df filtered over here. And okay, so if we just do that, then all the rows will be shown of the flower that we selected. So let's first see that it is running. And if I select isetosa, it will show me 50 rows because it has 50 rows, right? And if I choose vertical, it will increase the number of rows, but we don't want that because it's kind of too much data on web applications. So what we can do, we can simply sample the data. So what it does, the sample function of this is of Pandas, and what it does, it samples 10 rows from all the data, from the whole data frame. So it just picks out 10 rows and based on no conditions. So it randomly selects it. So let's see what happens. So these are just 10 rows. As you can see, I cannot scroll, and as I can select, it will change the number of rows because it's sampled. So as you can see, it changes the number of rows. If I deselect it, it will change the number of rows, as you can see. So if we can even decrease the number of rows to 5, that does not matter. So now we have the data frame in place. So what do we need right now? We need the graph that we have in the deployed app. We have a bar chart over here. So we need to see how many, like what is the data representing, right? So we have 4 variables in the data set. It's a sepal length, sepal width, and petal length and petal width, because it's the dimensions of a flower. So that's what the 4 dimensions that we have. So as the data frame changes, the bar chart also changes. As you can see, the bar chart will change if I deselect this. And so it did. So how do we do that? So we will use Streamlit's bar chart. So st dot, okay. We will directly do that. st.bar chart. We will put data as df filtered because that's the data that we filtered. And then I'm sorry. Yeah. df chart. Okay. What did we do? We can do one thing, because we don't need 5 samples, right? Or we don't need 150 samples. So what we can do, we can do this sample 50. So what this means, it takes on 50 random samples from the whole data frame. I will show you if we remove that, then what will happen. So we will do that afterwards. Okay, so we have this chart, and then what I will do, I would locate all the rows. So I will show you how this goes. Okay, so what I could do, I could also remove this, right? So we can give the whole data. But the problem with that is if we remove this, then there is a string variable, there is object variable that we cannot give to a bar chart, because a bar chart requires only numbers to represent, right? Because we are giving numbers on the y-axis and the x-axis. So that's why I'm going only the first 4 columns and all the rows that are in the df chart. So that's what I'm doing over here. And then I will use container with equals to true. So what it does, if we have a container in the Streamlit, I'll show you that. So this is in development that we are doing. So this is a whole container that we have on the web page, and so it minimizes. So if it's completely responsive, so if we reduce that, so it's completely responsive. That's why I did that. So if you increase the data, or if you change the data, the bar chart reflects. So what we can do, so this is done. So we can do some spacing over here. So it's a really simple thing that we can do. We can give some text variables. So this is a easy way of giving some spacing between the objects that we have. So yeah, that works for us. So now we have the data in place and we have the interactive UI in place. So now we need to have a machine learning model to interact, right? So let's get onto with it. So we need to import some more libraries for it, because we need sci-kit-learn for the machine learning part. So yeah, let's do it. We need to import train test split, because yeah, and we need to interest split because we need to split the data into a training set and a test set for the training part. And then we need logistic regression, because as you can see, this data is a classification problem. So that's why we will be using logistic regression for that. We can use many other models, but this was a pretty simple one. So yeah, and there's a time constraint for us. So that's why we are using this. So yeah, we have logistic regression in place on the linear model. And yeah, let's start for the development part. So now we need to split the data into X and Y. So we can simply do that. That's what I did above. So we need all rows, we need all rows and columns till 4, because the target variable is the last column. That is a species column. So we need to give it to Y. So how we will do that? We can simply do all rows and 4th column. This is colon 4 and this is only 4. There's a huge difference. Colon 4 means 0 to 3 and 4 means just the 4th column, right? So we have those and here. So xtrain and xtest, yeah, and ytrain and ytest. So what is this? These are the 4 variables that we will be using for the splitting part. So we have X and Y, and for the random state, we can give any number. I can give 101. So this means that if have the data in a particular manner for the training part, that's what you will be getting when you clone this repo and run it. So we have this, and then what we can do, we can simply instantiate a logistic regression model. And what we can do, we can fit the model on the training data. Yeah, we have the model that got fit on the X-train and Y-train. As this is a supervised learning, so we need to give the Y-train also. So yeah, now we have this. Okay, so this is the training part. So we trained the model and we got the model in the model variable. So now we need to interact with the model on the UI. So what we will be doing, we will be adding some sliders, as you can see over here, and whatever the value changes, we can simply click the predict button and it predicts the flower, what it is actually. So we will be all doing it right now. So what we can do, we can get these sliders from ST, that is Streamlit, Streamlit.slider. We can give a simple text for it, is a simple length, and then we will give the starting value the ending value, and the default value, right? And the step. Okay, I explained that all. So this is the starting value that we'll be having of 0. The ending and the maximum value is 20, and the default value is 2. So it can be anything, right? And the step is 1. So if you increase, it is a step of 1, like 2, 3, 4, 5, 6, things like that, right? So that's what it is. And so we need to copy it for all 4. So sepal length, sepal width, petal length, petal width, right? So we can simply just rename it sepal length, and it is sepal width. Now we have petal length and petal width, right? So you can rename this variable as you want. So I just got an extra one, so I will remove that. So these 4 variables will be holding the value that we select at a particular time. So the sepal width has 2, petal width length has 2, and the petal width has 3. So these all values will be stored in these 4 variables that we will be using for the image showing part and the prediction part, obviously. So now we have the values, and now we will be showing a button over here, st.button, and then we can put a text over here of predict. So as you can see, it's a really simple thing that we can do, and with a single line of code, there's a button. But in HTML, or if you're using HTML, then there's a bunch of code and CSS and JavaScript and things like that. So there's a button. Okay, so we will be using now Python over here. So if button. So what it means, so when you first reload the applications, the button value is false because it's a Boolean variables. As you can see, it's a bool. As I hovered over here, it's a bool. It will be false first, but if I click on it, it will be true. So if button, then we will come in and we will predict it. Model.predict, because we have the model above. As you can see, we have the model over here. We can simply predict it. We will give a 2D list because the model requires a 2D list. So yeah, so what we will give first, we will give first s length, s width, p length, and p width. So the y prediction will variable will have a prediction of either iris setosa, iris versicolor, or iris virginica. So then what we will have to do, we will have to see that what the prediction is and show an image respect to that. So what we can simply do, we can see the y predictions 0 with because this is a list and we need to get the first value of it, the first string. If y 0 is iris setosa, so we can simply copy that from here. If it is that, then we can simply show st.sub header of y pred 0. So what it does, it shows the header that what a prediction is. It shows the string, and then it will show the image. So what we will do, we will just simply call the st.image part, and then we can do images and setosa.jpg. So we can go into the images and the setosa jpg. So we can put that in a string and then put the width of 300. So that's what I was going through. And okay, I'm sorry, this is a double equals to. So we will be doing that for all the 3. So yeah. So if it is what's the string? If it is versicolor, we can simply copy that and put it over here and simply versicolor. And simply, if it is virginica, we can copy the text from here, because I am copying because there are some mistakes in writing. So that's why we won't have a problem with that if we copy. So then virginica, yeah, it works. And then yeah, that is it. So now what the problem is, okay, I'll come to that afterwards. So when I save it, so yeah, we can simply So it's loading because the first time that I was using that, so it takes some time for the first time. And yeah, we have some predictions. We don't have some prediction, but we have some default values as 2, because we select that, and when we click on predict, it gives us the prediction of isotosa. But if I increase these values, for example, to 11 or even 12, I don't know, then let's see what the prediction is. And the prediction can be very generic. So yeah, okay, so this is the complete thing that we created. So the problem is that every time we are reloading the application, the whole data gets trained again and again, and then predicts it again and again. So this works because data is fairly small in this case, but still we can, require model of pick. So I'm going to delete that from here. Okay, so let's include that. So what we are going to do, we're going to pickle the model. So I can simply import pickle. And then after the model fitted part, because the model got fit, and then we can simply pickle.dump. So what it does, it saves the model. So we can use that afterwards. Pickle.dump model. And okay, so we need to first open a file. File open model.pkl. pkl is the extension for pickle, and we will be using WB writing of binary because yeah, it's a model, so it will be binary. And then we will put the file. So when you run this first time, it will create the model, and it will save that into a pickle file. So the next time you can simply simply call that model and remove all of this training part. So we will do that right now. So when I save this, and when I run this, so as you can see, the model was created, right? So what I can do, I can simply comment this out, or even can remove this, and we can simply read the model. So how we will do that? We will simply read it, and sorry for that. I'm going to explain this all. So what I did, I saved the model first, but now as I got the model, now I'm going to read it. So what I did RB, which is the abbreviation for read binary, and then I load the model into a variable of model. Sorry for that. So yeah, so everything is same. The main advantage in doing this is that now we don't need to train it again and again. So yeah, the model is created, and now when we save it, the model is there that when we did it. So yeah, here it is, and it's working. As we can see it again. Okay, it's just random values. So yeah, Virginica. So yeah, we need to see the data, because the data is like really close. The values are really close, 2.9 over here, and above is 3.5. So that's not a difference much. So we can give a step of much less, right? So that we can do afterwards, not a problem. So yeah, so that is it for the development part and the model creation part. So now we will be more diving towards the deployment phase. So what we can do, so yeah, what we can do first, we can go through a simple command that we will be using, and then I can explain why we will be using it. Okay, so what are we going to use? We are going to use 2 Azure services. So the container registry, it's Azure service, and app service, which is also an Azure service. So what the container registry does, it helps us in developing a Docker image. So you don't need Docker installed locally, or you don't even need to, open Docker and, do worries about that. So you don't need that, right? So you just need to create a container registry and just issue this command. So what this command does, it creates the Docker image and it uploads that onto the Azure. So after that, what we can simply do, we can create an app service on Azure and just connect that container registry to this app service. So that's what we are going to do the first time, and that's that. So it will be completely deployable and completely be available to all of you. So I'll also share the link at the end of the session, so you can interact with this application. So yeah. Yeah, I'm sorry for that. So let's go on to Azure. So this is Azure. So if you don't have an account, you can simply create a new one. So you don't even have to put your credit card info. You get 30 days free trial. So that's what I did before. So it's completely free. So you can, as you can see, you can even search for container registry. If I search a container, there's our container registry. So what it does, it saves Docker image. It first creates a Docker image and then it saves the Docker image onto the cloud. So we can simply create it. So it's, as you can see, it's a really quick process in developing and deployment. So you can choose a subscription. If you have a new account, you get a Azure subscription 1, name something like that. And we can even create a new resource group. So I can name it webinar. Yeah, it is available. And the registry name is Iris Registry, Iris Reg. This is the name of the registry. And then we can select a location. So you don't have to worry about the location right now, because as you are learning, so it's not a problem that it is like too much available or not. So yeah, only these 3 things you have to fill, and you can simply review and create. So yeah, it takes some time for the validation, then we can simply create it. So it takes some some seconds to create it. And then after we issue the command, we can have some questions if you have. So it just takes 5 minutes. So yeah, let's wait. So yeah, everything is being done. So yeah, guys, we will be executing one command that we have. So for that, we need to install Azure CLI. So this is a simple link that you can find it on Google and of installing Azure CLI. So what you can go simply on this link and installs a package that you can run simply, and and just click on next and next, and it installs Azure CLI. So what it does, you can the advantage of Azure CLI is that you can interact with the whole Azure ecosystem without even going to the portal. So that's what the advantage of it, right? So we can either execute this command or even work on it on the portal. But as it is kind of a time constraint, so we're going to do that. So yeah, you will first have to execute one command when you install the Azure CLI. So I'm going to remove that. First, you will have to do AZ login. I've already done that, so I won't do it again. So when you enter AZ login, it will open a browser and you will have to log in into an Azure account. So it's just a one-time thing. So you have to do that, and then we can just simply paste this command. And yeah, let's see. So what it is, first, okay, let's explain it over here. So the first is the container registry, whatever the container registry that we created. So the name is Iris Reg. And then is the resource group. The resource group is webinar, and the image of the Docker image. So we can put anything that we want. So it's kind of a suitable name. So that's why I put Iris image over here. So yeah, let's change all these names. So the image name can be I can increase the font. Image name Iris image, and the resource group names can be changed to webinar. And then we can have a container registry that we just created of name Iris Reg. So that is it. So just you need to execute this command, and it creates a Docker image and uploads onto the container registry. Sorry for that. I just click enter, and will take some time to create image. First create a zip folder, then create an image, and then upload it into a container registry. So while it is happening, we can go into Azure and create an app service for us. So we will go to app service. So we need to deploy the application somewhere, right? So this is an app service. So we need to create an app service. So let's go to create. So it's loading. I will choose a subscription of our custom I'm sorry, I won't create a new resource because we just created one named webinar. So there it is. And we can simply name it Iris app. Okay, it is already taken. Iris app, I don't know, webinar, anything, because it's just internal purpose, because I'm going to delete it after this session. ISAP webinar, and then we are going to use Docker container over here because we are not using directly uploading core, we are directly uploading a Docker container. So that's why we are going to use Docker container, and that's it. So you just have to, choose 2 or 3 things, and everything is done automatically for you. So just create, review, and create, and let's just wait some moments, and then we can, when it is validated, we can simply create it. While it is creating, let's see what the progress of it is. So as you can see, the Docker has been creating. So I don't have Docker even open over here, as you can see. So it's completely, Azure Container Registry is completely doing everything for you. So it's preparing the images, it's preparing the hierarchy of images, and you just ran one command, and you don't even have anything locally. So it's creating the images, and let's wait some time. As you can see, it is completed in 1 minute and 20 seconds. So it just takes 1.5 minutes to create the Docker image and even upload that. So we can even go to that container registry and see if there's an image that we just uploaded. So yeah, let's see. I will have to sign in again. Not a problem. While it is doing that, we can also, as you can see, the app service is created. So it's just takes some moments that. Okay, so this is a web application that is completely manageable by Azure. So you don't even have to, control the scaling or the horizontal or the vertical scaling. So if you can browse, so it's a default web page that we have. It will take some time to, load for the first time. So till that time, we can go to the container registry that we just created. And the name of it was Iris Reg. And then we can go to repositories because that's where we the images are uploaded. So what was the name of the image? It was Iris image. So as it is over here, we can simply go over there, and the latest version is loaded. So this is the whole code that we just created, right? So we can go to Iris app, we can go to deployment center, and we just have to do this the first time that we create the app service. So it's just the first time that we do it. So yeah. So as you remember, we chose the Docker container when we were creating the app service. So that's what we will be choosing over here. And then we will use from registry source, we will be using Azure Container Registry because that's platform as a service. And then we will be using managed identity. So the managed identity is a person that is logged on to this Azure account. Because if you use admin credentials, then you will have to go to Active Directory and create credentials. So that's kind of a tedious task. So that's why I chose manage identity. So you just have to choose the container registry from the drop down. So that is Iris Reg. The image name is Iris image, and the tag is the latest tag. As you can see over here, it's the latest tag. So we can simply type it out, and that is it. So we can simply, okay, yeah, we can simply save this. The saving is very important. Okay, so we opened the app service before, so that is the default web page that you get when you deploy the application, right? So it will take some time to save the changes that we just did. So it takes some time, and it takes 3 to 4 minutes to get reflected onto the deployed version of the application. So let's just wait for it. So if you guys have any questions, you can ask right now.
So we got that question in. So this person wants to know, there's another Python UI tool. It's called Python TK. And can that be used instead of Streamlit?
Yeah, anything can use. You can even use Flask. You can even use Fast API. So those are all Python packages for REST APIs, right? So this is it is a deployed version of application that you can use for REST APIs or even web applications. So you can use React, you can use Angular, you can use whatever framework that you have, Java, Python, anything. So anything can work over here, right?
Mm-hmm.
So yeah.
Okay, that was the only question that came in. This person says thank you. Are there any other questions? I'm going to go through the chat, make sure I didn't miss any. We've had some questions about the recording. So yes, there will be a recording available. It'll be on Data Science Dojo's YouTube channel, as well as our tutorials and event pages. It will be sent out via email. So if we have your email address and you RSVP'd for this event on our website, we will definitely send you an email with the recording, the link to the recording, as well as the resources that Ibad has shared with us today. Otherwise, if you haven't signed up for our newsletter or joined our LinkedIn group or Facebook group, just follow us on one of our social media channels, and you'll definitely see the recording.
Thanks, Nathan. Thanks a lot. Okay, so it takes some time to be affected onto the deployed version. So it takes around 3 to 5 minutes as I measured. So yeah, we can simply do a hard reload after every 2 or 3 minutes. Yeah, so as you can see, something came up. So yeah, so it takes some time to load for the first time. So this is the UI that we just created, right? So ISApp webinar. So yeah, let's take some time. The first time only. So yeah, that's it over here. So if we can predict, so let's see if it predicts. Yeah, it predicts. It predicts correctly. We can even interact. Let's see. Yeah, the graph changes. Even if you can download the graph as a PNG. Yeah, it's over here. So it's really a really good tool of Python that we can use. I'll even share this link with you guys so you can even, yeah. You can even open it and it will open it on your laptop. So what we did, we just created an application locally. We didn't know how it would work when it is deployed. We just used Streamlit and Python to do this whole task. We used Azure Container Registry to create a folder, to create a Docker image, and then upload it onto Azure. We didn't need any Docker. We didn't need any Docker understanding. So yeah, when this came, we can just go through line by line, as I told you before. So so a Docker image, what it does, it creates a containerized application that can be used on any OS or any infrastructure even. So what it does, it uses 3.8 Python, and the application that we're working with is app.py. So that's what I named it. And the working directory, it creates a working directory of app. That's what we did. And then this line is really important because we need to have a requirements.txt file, because when we are creating a Docker image, we don't know what packages are used in the code, right? So that's why you need a requirement.txt file. So sorry for that. So you need that, and you need to expose the default port of Docker. So that's 80. So now we are simply uploading all the directories and all the images that we have onto a directory that we name as Streamlit. Also, we put a config.toml. So what it's a file that is copied from online. So what it does is it's really important from Streamlit. Like if you're deploying a Streamlit application, so you need this file. So what it does, it has some default configuration like disable watchdog warning, sharing mode, things like that. So it's not important. So it's just a file that you can even find on the GitHub repo that we shared with you a while back. So that's it. And the working directory as we showed over here. And this is a default entry point of the application. So as I told you, when we are running the application locally, we run Streamlit run app.py. So that's what I did over here. Streamlit run app.py. So this is a Docker file that we created before. So yeah, it took just 10 to 15 minutes for the deployment, and around 30 minutes for the development. So in around 45 minutes, you can develop a whole machine learning application. So the use cases, what I did with my development and my deployments, what I did, I included these URLs onto my resume. So it's a really interactive session when you go for an interview, or an interviewee asks or interviewer asks for something, so they can simply interact with this application that you just created, because a Jupyter notebook is of no use in front of an interviewer, right? Because they can't interact with that. Obviously, there's so with Streamlit you can even incorporate deep learning or computer vision. So if you guys have any requests, so you can ask us, and we will get back to you with a new webinar in the upcoming days. So yeah, that's